go because this is going to die anytime. All right.
Oh, did you see your kids this morning?
Did I see mine?
Yeah. Are they feeling comfortable?
You know, they were just, they're there, and they're going to take it. A few of them had fevers, a few of them were getting colds. It's a party in there today. But no matter what, they got something to eat, they got some coffee, hopefully. They had some snacks for in between. It's the best I can do. One of them has fevers. All right. All right. One thing is that's recorded. Okay, so. Alright, cool kids. Hey, I have to stay over here because literally, like my wire, none of my USB ports are working. Like it's on the way out. It's rough. So I'm over here so I can be near the mouse. I'm over here so I can, if something freaks out, I don't know. Pray over it. Anyway, so just kidding. There are much more important things to pray about, but we do pray for God's grace, as always. Here we go. We are in section 12.2. Our goal today, we're almost done, is to finish 12.2. We're going to start 12.3, and we can do it because we're HonorsPrecalc. All right, here we go. Woo! We did not get to finish this one, but how would we? Okay, write it down. It was at the very end of yesterday. I asked you guys how we would start. And technically, I need to, well, I'm not going to take that away because I have to rewrite it. I'm going to do this. And then I'm going to cut it. Okay. What's the very first thing that we should try with any limit? Yeah, plug it in, because we love substitution, right?
Yeah.
It's like 3 points. We love 3 points. We love substitution. If it works, it's great. Problem is, did it work? 0 plus 4, square root of 4 is 2, 2 minus 2 is 0. But, is 0 over 0 an end of a limit problem? No, what is 0 over 0? A beginning. Keep going. So what appears to be an end is not always an end. It might just be the beginning of something new. Ooh, life lesson. So, okay. L is now an outlawed word, letter, concept. Unless it is used in a joke form. But if there's any seriousness, we're aiming for W's. Okay, so we plug it in. We get 0 over 0. Keep going. Oh no, it has a radical. If it has a radical, what did we learn yesterday that we should do?
Keep going.
How? By what? Yeah, what's that called?
Switch the second sign.
What's that? The conjugate. Alright, Ella for the win. So, the conjugate. But you guys were right with the idea. You take the term that has the radical, you multiply top and bottom by that term, but one thing changes, and that one thing that changes is the sign. All the signs? No. Just the sign between the terms. Do you guys see how there are two terms? It's kind of like a binomial, right? Okay. The sign in between the terms only. Now, how do I proceed?
We can just multiply like foiling, but technically, since it's the binomial thing, once we do it, the -2 times the square root of x plus 4 plus the 2 times the square root of x plus 4 cancels out. So then we just have the okay. No, I lost y'all. I know. Yeah.
He's saying if you were to do the entirety of FOIL, the first, which the square root cancels because I have a square root squared, right? Hence where I got this term, x plus 4. The outer plus 2 square root of the inner minus 2. Okay, I wrote it in backwards order, but that's okay. And then the last, if you do all of FOIL, Sean's like, but technically if you do all of FOIL, the middle will cancel because these are, conjugates always are differences of squares. So you could do the shortcut multiplying a difference of squares, and you just end up with the first squared minus the last squared. You could do the shortcut, or you could do the entire FOIL, and every time, what's going to cancel? The middle two, the outer and the inner. That's what Shauna's trying to say. You could do all of FOIL, first, outer, inner, and last, and then cancel. Or you can see the shortcut. What do I do on the bottom? Do you remember?
Just keep it.
Keep it. Keep it. Because who was the problem originally? Where was the problem? That radical is giving me some problems, right? I can't factor with a radical. I can't divide out polynomial division with a radical. He was the problem. So I'm leaving the bottom the same. And I'm going to see, well, maybe this made things on the top a little bit better. All right, cool kids. Now what?
Let's simplify.
Sure, keep going. So let's simplify. If we can simplify, on top, don't we just get x plus 4 minus 4? Oh, what happens to plus 4 minus 4? They cancel. So what do we have left alone? Okay. So I have just x all over. What's in the bottom? X. And then the x. Okay. Exactly. The x is reduced. Pause. Something super important. When I cross out a numerator, what remains? A 1 remains. This remains in the denominator. True? So I can go ahead and say I have the limit as x approaches 0, 1 over, but wasn't the point to solve? So I still have the limit written because I still haven't found the limit yet. So what do I do now to find the limit? See if it works to plug in. Square root of 0 plus 4. Did you just shush someone coughing?
Yeah.
That was rude. Okay, so. All right. I shouldn't have distracted you guys. The answer, 1/4. The answer, 1/4. Now, pause. Do you guys know how I said that I'm going to be really picky about you guys plugging in at the beginning, actually checking first exactly what you get, even if it's over 0. I need to see 0 over 0 before you keep going. I actually want you to write KG or keep going. I want you to show your work along the way, but here's something else I'm going to be picky about. Because some of you, if you look at your work right now, I would take off points, and here's why. Did you keep writing limit after every single equals until we got to plug in to solve? If you didn't, write them in now. You need the limit as x approaches 0 next to every single term until. When did I say you can stop? Until you plug in. Until you plug in and are finding the actual limit itself. Now, some of you are like, that's dumb. Believe me, just trust my years of calculus experience. Keep writing the limit because it tells you you're not done. It tells you you're not done until you can plug in and simplify and solve. Are you guys tracking?
Yeah.
Okay. So all the highlighted things are very important to show. Well, I mean, everything is very important to show all your work. But anyway, the highlighted things are different steps kids tend to leave out, and I am saying don't you ever leave them. Okay? Okay. There is, the version of taking an L on homework. Not all of homework, but on a problem. Like, I've worked on it, I've tried my strategies. I tried to plug in, I tried to do factoring, I tried to do dividing. If the factoring, I didn't know what to do. I tried to do multiplying by a conjugate, but it didn't have a radical. I'm stuck. Okay, you're not taking a loss. What you're doing is saying, I don't know what to do. So go check it out in your graphing calculator. If you don't have your graphing calculator, go graph it on like Wolfram Alpha or Desmos or something like that. See what it looks like. Now that is not the ideal situation. We don't want to be stuck to our calculators because ultimately the calculator is just a tool that is only, to be honest, in most math, sometimes allowed. It is great for discovery. It is great for what we used it for as far as tables and graphs and being able to zoom in and get really close without doing tons of annoying number work. Bless you, bless you. Our goal is to be able to do everything by hand, but if you come across one where you're like, I just didn't know what to do, check it out in a table, check it out on a graph, see if you can find the answer, and then work backwards and say, okay, how did I get there without the calculator, without the table, without the graph? All right, let's go ahead and keep going. Yep. What if the math gets a little funny? What if the math gets a little funny? No. Our goal. Okay, guys, I put this just to say if you come across something that you don't know what to do, try your best with everything I've shown you. I'm going to show you a few more examples, but you always have like a fallback in the sense of homework. But no, I'm showing you other ones that you might think you can't do, but you can.
Yes, you can do it.
All right. What do you guys think? Okay, wait, no. You will always try to plug in first. So if you plug in 1 on top, what do you get?
0.
How about on bottom? 1 minus 1 plus 1 minus 1.
0.
What am I going to write after something's points?
Kevin Garnett.
No. But if it helps you remember it, then I say yes.
He does.
Would he keep going? So maybe not the best inspiration. Coming back. He's in the game. How about that? So, how do I keep going? Is there a radical? No. There's no radical. Okay, how do I divide out? We can try to factor. Not the top, really. There's nothing to do. Well, how do I factor a cubicle?
Like do like this, like grouping.
Oh, okay, we could try grouping. It doesn't always work, depending on how complicated, but we could try grouping. What do we get if we group? Okay, pull out an x squared. What do we get inside? Oh, nicely done. I was going to remind you later, but you guys caught me. That's better. On top of it. Pause, come back, finish the problem. Pull out an x squared. What do we have? Got it. Then, can't I do an understood 1 if that helps you? X minus 1?
Yeah.
Now, how does grouping work? Where do I go from that? Yeah, in essence, you pull out the x minus 1 and you have x squared plus 1 remaining. Did that help anything?
Yeah.
Oh, grouping was nice.
Yeah.
Look at that.
What remains when you reduce the numerator and denominator? There's still a 1. Good. How do I finish? Yeah, I stopped writing limit because I got this thing now, right? 1 squared plus 1 is... Now, if a few of you guys are like, I'm not sure that grouping thing always works. A, you're skeptical of grouping. And B, you're like, I'm not sure I would have thought of that. Even though the bottom is bigger than the top, we never really divide when the bottom is bigger than the top. We could technically still kind of do some division. We could go ahead and we could have plugged our x cubed minus x squared plus x minus 1. We could have seen if x minus 1 did go in, kind of like a synthetic division sort of deal. We're seeing if x minus 1 does go in. The 0 over 0 seems to say there should be a common factor somewhere. And when we would go ahead and subtract, we would go ahead and see that yes, x minus 1 does go in. But kiddos, how would we use this information? We could do division. We could divide the bottom divided by the top. We get x squared plus 1. What would we have had to have done with that information? Plugged it in, but where? To the bottom, not the top. So if you divide backwards, if you take the bottom divided by the top, the answer you get needs to go in the denominator. Usually we do it the other way. It's top divided by the bottom, and the answer goes in the top. If we do bottom divided by the top, it needs to be 1 over that answer eventually. Just a quick heads up, because some of you might be like the grouping I'm not so sure about. I wanted to let you guys know you can do polynomial division, except when you get it. Since you divide it backwards, that does need to go in the denominator. So you could have 1 over that. All right, so that's one way. If you have a cubic, you're not without The ability to proceed, you just have to proceed carefully. Grouping, factoring, maybe polynomial division. What about this guy?
That is pretty.
What in the world? I kind of want to look at this.
Don't worry, we've been playing with weird things all year just to get up to this point where we can do farther, higher. Okay, plug in. Good. No! Plug in. That's okay. You can go ahead and write it. I'm just plugging in 0. You're okay. You're okay. Wait, me? I plugged in 0.
Zero.
Community, can I do keep going at me? Can I do keep going at me? Well, the table thing, I'm going to show you 2 different ways. And technically, there are 2 different ways that you guys have already seen this year. I just haven't really spent a lot of time showing you both different ways. Well, the long story short is that I somehow need to simplify. Factoring, that doesn't really look, no. Polynomial division, how would, no. There's a radical? No, there's not a radical, so no conjugate. Kiddos. Usually, what do we always need to, I'll say always. What do we always need to do when we have a complex fraction? To simplify. Simplify, right? And we could think of splitting. I think that's going to be more complicated for most. If it was like x minus 1 over x, maybe we'd split it. Sounds like a 1 over x plus 1 over x. I would say either think common denominators or think my creative simplifying complex fractions. All right, focus in, focus in, focus in. This will be very helpful if you guys can finally get what I've been showing you all year. The old-fashioned way to simplifying this problem would have been common denominators. That's what you learned in elementary school, how to put together fractions that have different denominators. You have to get a common denominator. And who can't go together right now? The numerator. What would let it go together? A common denominator. Right? Okay, so when I multiply top and bottom, I end up with the limit as x approaches 0, 1 over x plus 1 minus wait a minute, isn't the whole point there's common denominators now? So maybe I can put all of this over x plus 1. So the point was that I had common denominators, so I could put those 2 together. You think they're flying under the same flag, so they can come together. I have 1 minus x plus 1. How could I simplify this expression? Something I can do. Anything. Anything I can do. Yeah, reciprocal of what though? Who's in the denominator? Well then, he's what I need to multiply by the reciprocal of. What's his reciprocal? Yeah, think of him as over 1. Now I have a top fraction and a bottom fraction. I can multiply by the reciprocal. The old-fashioned way would say, okay, take the numerator. Wait, can't I simplify the numerator? Can I do 1 minus, distribute my negative? Okay. Times the reciprocal of x over 1 is 1 over x. True? Now those aren't absolute value bars, guys. Those are 1s. What am I going to do with 1 minus 1? Yeah, cancel out my 1s. 1 minus 1. So I'm going to go ahead and keep simplifying. Don't I have an x up top and an x down bottom? What's going to happen with those guys? When I reduce what's left up top? Now what can I do? Yeah, plug it in. Now, Is this really that weird based on other problems you've done in the past that involve fractions? Complex fractions, a fraction in a fraction. Hopefully not. Hopefully multiplying by the reciprocal rings a few bells. Top divided by bottom, you can do multiplying by the reciprocal of the bottom. We have some addition, subtraction canceling out. We have some common factors reducing. But is there a different way of approaching this problem? And I would say yes. And some of you remember my way and some of you don't. It truly does cut down on the steps. And if we can cut down the steps, if we can simplify the process, maybe we can eliminate the probability, the possibility of you guys making a mistake. That's the idea. If we can cut down the process, if we can simplify the process. Remember, the limit is -1. Maybe we can cut down how many mistakes you guys might make. My trick is to multiply top and bottom by, if there are multiple denominators, I would get the common denominator, like if there was an x plus 1 there, and if I had, say, like a 3x here, I would take both denominators. But I don't have multiple, I only have one denominator within my fraction. So I would multiply top and bottom by that denominator. When I'm multiplying, it's usually pretty important to make sure that you realize what's being grouped together. The joy of my way is if you multiply the top and bottom by that denominator, kiddos, what happens as you distribute into that term that had that nasty denominator? They reduce. They cancel out. Reducing is the better way of saying it. And become 1. But I still have a minus and I still have to distribute here. So what happens when I have x plus 1 times 1? Okay. Then as I go to the denominator, what am I going to do? Wait a minute. I skipped. Holy cow, look at the left, guys. How much did I skip? I skipped the common denominator. I skipped the fraction and fraction and making the fraction and multiplying. Wow. I skipped all of that. Yeah. But you have to be careful with it, right? But if you learn just to look at a complex fraction and say, hey, who's the denominator inside the fraction? Multiply top and bottom carefully. Bless you, bless you. That's going to look so much nicer. And then what do I have to do? Yeah, finish it. Like, I don't know, what, distribute the negative? Yeah. Okay, so finish it by distributing the negative. So I'm going to end up with... Isn't this kind of where I end up on the other one anyway? Where the 1's cancel? Then the x's reduce. That might have been a little too fast for some of you guys, but you've already seen me do it once. If you are not plugging in, you rewrite that limit until you plug in. Dun, 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 dun. Dun, dun. Now, I did that fast, but it's because, if you guys notice, this method, if I multiply top and bottom by the little guy that's stuck in there, that little denominator, I get to skip from the problem down to this step of the answer. And I get to skip all of that.
Wow.
That is cool, but if you can't do it properly, then maybe it's better just to stick with the old-fashioned common denominator multiplied by the reciprocal way. But once again, if you go my way, you get to skip all the way down to this step, and then we finish the same way that we did over there. All right. Same amount of room? I don't know. Up to you guys. Alright, cool kids, with that. I know. This is important, but it's not hard. Calm down, you little whiners.
Only L in pre-calc.
Sorry.
No, it's going very good.
Sorry, I couldn't read your face. I was a little bit of saltiness. Good.
Hey Ryan.
Multiple choices done, yeah?
Misty, on the calculator, there was no fewer than 4 integrations in that change. It was bizarre.
Good thing we talked about it. But shh, don't tell me.
Is this recorded?
Yeah. I'm not gonna like type it. No one will find it unless they're reading and watching it. You okay?
I ran a little eyebrow.
No fewer than 4.
No fewer than 4.
It's a huge topic. Alright, one-sided limits. Oh, you guys are writing anyway. Alright, keep going. You go back in, check on Jacob Shabinsky. Tell him I agree with you, check on her.
There's just some weird. Just weird. If you have any hope in calculus, pay attention to this. It's important.
Fine. He didn't say it was hard though. He said it was important. Okay. It just makes next year start off much easier. I guess that's why I'm able to. Who knows? I missed it. It's okay. I'm on the side, but I
asked Sean where we're going and he said, and I said, no, college.
Well, he was going back to the test.
I'm still getting here and now.
Alright. What goes in the quotation marks? What I mean, well, actually, I'll be a little more specific. Don't worry, I'm zooming out. Do you guys see how there's a C plus? Not as in the programming language. C plus? Oh no, it's a minus. I put the wrong one. Would have been C plus plus though. C minus. There's C plus too. C minus. C minus means, oh guys, hold on. This is not really that new. It's literally just notation. Because we've been talking about how to come from, oh, hold on, from the left. I forgot which one's mine. From the left, which we've been saying coming from the left is the same thing as from below. Have we talked about coming from below? That was your cue to say yes. Thank you. Table and graph. We had to come from 2 directions. Pause. Think Mean Girls. You have to be able to have a limit that agrees from either side. So you have to come from below x equals a or x equals c, and from, what would the next, guys, how am I going to fill in the next blank? Just use your process of elimination.
Right.
From the right, what else am I going to fill in?
From above.
From above, what else am I going to fill in? C plus. No. So what's new? What's different? What's different is that we can split up the one-sided limits and we can come just from one side and actually answer a limit problem. So remember, a limit, as x approaches c, no plus, no minus. In the exponent, it's up. It's not like next to. It's in the exponent. The plus is in the minus. The positive and the negative. These are just notations telling me that I'm only coming from one side and telling me specifically which side to come from. If there is no plus, if there is no minus, remember, the one-sided limits have to agree. I have to come from both sides and ask myself the question, is the limit the same? But this lets me kind of split up a problem and say, what's going on just from below? What's going on just from above? And then I can say the overall limit as x approaches c, let me write it, will only exist if both of these limits from below and from above are the same. Which we've talked about. That's not necessarily new. But the limit, what I mean by the limit is the limit as x approaches c with no sign of f of x exists and equals L if L equals L1 equals L2. I guess I could put it like that. So the limit as x approaches c with no sign, that's the two-sided limit, that's the definition of the limit coming from both sides. Whether you come from below or above, either way you come, both limits have to agree, have to be the same. So it's just another way of basically noting what we've already been doing. You have to come from below, come from above. But now we can actually answer those. Well, what is the limit just from below? Well, here's the notation of how to write it. What is the limit just from above? Okay, here's the notation how to write it. And so with all of that you guys have been writing down, hopefully we can go to this example now. I want you guys to go ahead and throw this in your graphing calculator. How do we find absolute value? Math and then over, right? Math and then over. Throw this function in. I would use alpha y equals to make it a nice pretty fraction. If I were you. All right, so what did you guys get in the graph? Okay, we can wait. Make sure you have absolute value. Make sure you have parentheses around the top and the bottom, unless you're doing a nice pretty fraction. I guess parentheses aren't super necessary in this one because there aren't multiple pieces. If you guys don't have a graphing calculator, you can do like what I'm going to do right now, which is plug in -2, -1, 0, 1, 2, and just see what happens. We can always go back to the old school table with that. If I plug in -2, -4 over -2 is -2. If I plug in -1, also -2. The top turns positive, the bottom is negative. If I plug in 0, nothing. If I plug in +1, all of a sudden I get a +2. If I plug in +2, I also get a +2. Do you guys see a broken line? Now, if you plug in 0, does the function exist at 0? And the answer is no. Because you do have division by 0. If you plug in 0, 0 over 0 does not exist. The function does not exist. But if I plug in, and what am I thinking about? I'm thinking about this one right here, because if I plug in, I get 0 over 0 when I plug into my function. Remember, plugging in, we always try that first. For each of these, we get 0 over 0 if we were to start. Hold on. My ringer's ringing. But then I do still need to keep going for the limit. So the function does not exist. That's why I put holes. The function does not exist at 0. But the limit says, I don't care about what's there or what's not there. I care about the approach. So kiddos, this first one, letter A. What is the wording that we just wrote down as far as how to read the graph, as far as how to come from only one side and which side in part A? From the left. If I'm coming from the left, can you guys tell me what or where or how this limit is approaching? Or what this function is approaching, I should say. No. Yes. Do you guys see why it's -2 and not +2? I'm going to go ahead and erase my kgs because that's just the point of if you were to plug in, it all says keep going. So we're like, oh, well, we don't know what's going on. If we were to come from below, if we were to come from the left, we are approaching a height of, doesn't matter what's there, just what we're approaching, of -2, right? Okay, so we're going to go ahead and fill in -2 for that one. As we come from above, what am I approaching? +2. Do you guys see it? I'm coming from the right now. So I'm approaching a height of, doesn't really matter what's there, just what am I approaching? +2. So how do I answer, based on seeing the answers to these one-sided limits, how do I answer the limit as x approaches 0 of f? Because, you tell me why. Yeah, the one-sided limits have different values. Does that make sense? Okay. So is this page really that crazy, or is it just a new way of, actually a shorter way of writing from below and from above? Yeah, it's notation. It's a shorter way of writing from below from above. We don't have to do a table and the 1 point, well, on this one it would have been -0.00001 and +0.001. But you can just look at a graph and then just quickly show us some notation and then say, okay, sweet, the limit does not exist. Now, there's one other thing in this section I know is a tax section. Might not get very far in 12.3, but that's okay. Once upon a time, we saw this thing called a difference quotient, and we learned how to plug into it. Now, we didn't know limits back then. We didn't take limits of these funny difference quotients, but we did learn how to plug in function notation and how to think of f of cow. Just kidding. F of whoever's inside. It could be a cow, it could be an x, it could be a 3, it could be an x plus h, it could be a 1 plus n. I don't care. Whatever is inside the function, whatever is inside those parentheses has to take the place of the variable. So this one's easy because x takes the place of usually x, so it's no big deal. But this one's a little harder. F of x plus h, you need x plus h to take the place of. So in order to kind of demonstrate that, I'm going to go ahead and get some little different colored boxes out real fast. This one I'm plugging x plus h in to my independent variable, and this one I'm plugging x in to my independent variable. Everything else just gets rewritten. You don't have to do any plugging in. The only plugging in is for f of. The steps that you guys are writing say, find f of x plus h, aka take x plus h and plug it into the argument of f of x, plug it into the x, so the x comes out and the x plus h goes in. The x comes out and the f of x plus h, the x plus h goes in. And then the second one says, plug in both who you know f of x plus h is and who you know f of x is into the limit, and if you want, you can go ahead and say just the limit formula. Or we could say the difference quotient formula. And then you just kind of use algebra to somehow simplify and find the limit. To somehow simplify and find the limit. Using the other stuff we've done in 12 too. So the only way this is going to be a little bit harder, pause, you're okay. The only way this is going to get a little bit harder, guys, is before you can actually do the limit problem, you have to remember how to get what we're supposed to take the limit of. We're going to take this function, plug it in, simplify. It's the very end of homework, but see if you guys can remember the difference quotient from the beginning of the year. I'll go over a couple questions. It'll be basically homework questions tomorrow. Bye, guys. I'm going to go ahead and solve this one and post it online. That way you guys can see it if you want to.
I said don't tell me. Yeah, you'll see. You'll understand why. It's like 6 very, very easy. 26 or 25?
Oh, there were 26 points possible. I made it out of 25, so there was like a built-in bonus point. So then I did 26 minus however many you missed. close, and that's 19.
Five out of 20.
Yeah. 25.
After all the AP tests, I have really no class every day.
Oh, really? You're like, nah. What are you gonna do with your life, Sam?
Oh.
Have you tried doing any like programming or anything online?
I do some.
Okay, good. Good. I meant to ask you that.
I
Thought about
learned
it.
some when my sister started. I learned some, and
Oh,
also
that's cool. Is she
also
taking a
I-
class in college?
Huh?
Is Jenny taking a class
Yeah.
in college?
also I learned other languages before, so other languages I mean
Yeah, yeah.
computing. But so
What are you working
like
on now? Like, what's Jenny
normally
learning?
when I was young, I think I was about 10.
Uh-huh.
My father taught me C++.
Okay, yeah.
But now they don't use it anymore. They
Right.
use more of a Python. So I learned it again. But it's every computer language is similar.
Similar like problem solving, right? It's similar
No, really similar.
processes
Because
kind of.
everything they have if, else, and whiles. That
Yeah.
those are all same.
The
so-
connector words are.
yeah, but they're little difference in grammar.
Oh.